Hello, and welcome to the second part of the S500 with the Matek F405 flight controller build. In this section, we're going to be looking over configuration and getting ready for our first flight. Before proceeding, make sure that you have your transmitter and receiver set up in serial mode and that they are connected to your flight controller. Begin by connecting your flight controller to a computer that has Ardupilot installed via the USB cable. You should hear some Windows connection sounds when you first plug it in. With the Ardupilot program open, check that the COM port is the correct one and that your device is showing up, and hit the connect button in the upper right corner. You will then see a status bar telling you that it is connecting to your flight controller. After a few moments, this will be done and you will be connected to the computer and we can begin writing the parameters. Because the flight controller was mounted at a 90-degree offset, the first thing we should do is change the orientation that our flight controller sees itself as. In the upper left corner, hit the Config tab and then scroll down to Full Parameter List. This is the parameters that our flight controller uses. These are very raw and untouched parameters, and there will be a notice telling you to be very cautious when changing any of these. Once in the parameter list, we are going to use the search bar and search for AHRS. We are going to then look for AHRS_orientation in the list. Here you see that we have several different options. We are going to change this orientation to 2, which is the correct orientation for how we mounted our flight controller. Once we input 2 and hit enter, it will change to a green field telling us that we have a parameter that's changed. At this point, hit the Write Params button and that will write the parameter onto our flight controller. Once this is successful, go back to the Data tab in the upper left corner. Now, by moving the drone in several different directions, we should be able to see on the artificial horizon that it is orientated correctly. The next parameter that we need to change is our flight controller's motor order. Because we rotated the flight controller when we mounted it, our motors will not be in the correct order for our flight controller, so we need to change them. To do this, navigate to the Setup tab in Mission Planner. Once here, open the mandatory hardware tree and then click on the Servo Output tab. Once this opens, you will see a list of drop-down options. These are the different outputs and configurations that our flight controller is capable of. We are interested in the first 4 functions because our drone is a quadcopter, and therefore has 4 motors. If the directions from part 1 were followed correctly, then we want to change this order to motor 2, motor 4, motor 3, and motor 1. This will be the correct configuration for how we have set up our flight controller and our drone. If the build instructions were not followed precisely and you would end up developing problems, you may have to tweak this motor order yourself. Once this is done, the process should save automatically, and now your motor order will be correct. Our next step will be to disable the compass because the F405 flight controller does not have an onboard compass, and Ardupilot comes with a compass configuration pre-installed. To do this, once again navigate to the Parameters tab and this time search for compass_enable. Once you've found it, change the value to a 0 and hit enter. This will make it so that the flight controller no longer searches for a compass when it's doing its pre-arm checks. Once this is done, hit the Write Params button to save the parameter onto the drone. Once this is done, we also need to do the exact same thing but to the compass_use parameter. Similarly, change it to a 0 and hit Write Params. At this point, it's a good idea to save the parameters to a separate file. This way, we can easily revert back to our initial state. Hit the Save to File button in the upper right-hand corner of the screen, and then simply name and save your file. This next section will deal with the hardware setup. Navigate to the Setup tab in the upper left corner. From here, you will see a list of several different options. We are going to go through each one of these besides the bottom 2 and change our parameters. First, start with the frame type. The S500 is an X-type frame, so go ahead and click that. Once clicked, the option will save automatically. Next up is our accelerometer calibration. Once the tab is opened, you will see 3 different options. You're going to go through all 3 of these options and follow the instructions on your screen once the button is clicked. These options will require you to move your drone in certain directions and face it on certain sides when told to do so. This will calibrate our drone's accelerometer, and it will let it know exactly which direction it is accelerating in. It will also let our drone know which direction is up and which direction is down. Next up is the compass tab. Because our drone doesn't actually have a compass installed, we won't be using this. However, it's a good idea to uncheck all three of the Use Compass boxes. The next section is radio calibration, and it is one that you will see quite often. It is recommended to do a radio calibration every time you connect your radio and change any of the options in the radio itself. For this section, you're going to click the Calibrate Radio button, and then move all of your sticks and switches to their maximum and minimum positions in all directions. This will calibrate your radio and let your flight controller know what the min and max values for each switch are. Once you have finished this, you will click the button that says Click When Done, and this will save the calibration of your radio onto your flight controller. The next step is the extremely important ESC calibration. This is going to calibrate each of your ESCs and let your flight controller talk to them. Before proceeding, make sure that your flight controller and transmitter are plugged in and that a battery is also plugged in to your drone. Once this is done, you are going to follow each of the directions precisely as laid out in Ardupilot. Once these directions have been followed, our ESCs have been successfully calibrated. The next section is flight modes. For now, we are going to keep each of the options in stabilize mode. However, later on, you may feel like changing these. There are several items in the drop-down menus that can be selected, and they all do different things. The final section we're going to look at is the failsafe section. What these failsafes do is enable a procedure for whenever something happens, such as our radio losing contact or our battery dropping below a certain voltage. Now we are going to focus on the radio section, and in the drop-down menu, select Enable Always Land. This will enable a failsafe that in the event that our transmitter loses connection with our drone, the drone will perform an emergency landing and we will be able to recover the drone ourselves. Later, if a GPS is installed, we can change this back to enable always RTL. This will cause the drone to return to the position from which it was launched if it loses contact with the transmitter. With the failsafe set up, we are now complete with the mandatory hardware section of our setup settings. The next part of our setup is Motor Direction Test. This test is exactly as the name sounds. We are going to check the direction that our motors are spinning. Now in the optional hardware setting, scroll down until you find Motor Test and click on it. The important parts of this page are the throttle percentage and test motor buttons. First, find a throttle percentage that is the lowest percentage possible that will still turn all four motors. You may want to write this percentage down as it will be important later. Now, by clicking each of the test motor buttons in series, check and make sure that the motors are spinning in the correct directions that they're supposed to. The graphic appearing on your screen shows the correct direction that the motors are supposed to spin in. In the center of this illustration, you will see a box with an arrow on one end. That arrow indicates the front-facing direction of our drone. Now, using the motor test buttons and the graphic, we can check if our motors are spinning in the correct direction. If any of our motors are spinning in the incorrect direction, it is quite simple to fix. All you will need to do is unplug two of the wires that are connecting our ESCs to our motors and switch the places from which they were plugged in. This will cause the motors to spin in the opposite direction. Once this is complete, we can put the finishing touches on our physical build. It is advisable to put either torque lock or whiteout on every single fastener that is on our physical build. This will allow us to know whether or not one of the fasteners has come loose. We can also tidy up the ESC wires that are hanging underneath the arms using zip ties. The reason we waited to finish this until now was so that we could have easy access to the wires of our ESC so that we could change them to switch the directions of our motors. And with that, the physical build portion is complete. The next step will be setting the motor range. Step-by-step instructions for how to do this can be found at ardupilot.org/copter/set-motor-range. Using the throttle percent speed that we found when we were setting up our motors, we will be able to follow the directions on Ardupilot's website and by inputting it into some equations, come up with the correct values for parameters that we need. Setting these parameters will essentially set a minimum and maximum speed that our motors are allowed to spin at. Please follow the directions carefully and make sure that you double check every number that you put in. The next step in our process will be the tuning of our aircraft. Instructions for how to do this can be found at ardupilot.org/copter/docs/tuning-process-instructions. You're going to want to open the very first item located on this webpage titled Setting Up the Parameters to Prepare for the First Tuning Flight. This section is the most important and the one that we will be focusing on most. It details the parameters needed for our initial flight. Please follow these instructions carefully and exactly. Following sections are for the tuning of the aircraft to give a more enjoyable flight experience. This includes PID tuning and the option to do an auto-tune. Tuning the aircraft is highly important. However, because these videos are focusing on just the first flight, we won't be covering that content. That said, it is highly suggested that you follow the instructions on ardupilot.org so that you can have a correct tune for your aircraft. For now, we're going to do a very simple PID tune. This tuning won't be perfect, but it will serve as an initial baseline. Navigate to the Extended Tuning page in the Config section of Ardupilot. Once there, you will be able to see all of the PID parameters that we can change on our copter. The initial values provided by Ardupilot do not fly well with our configuration, so we'll need to change them. Change the values that you see here to the values that I have inputted, and you will be able to get your copter off the ground. Once the values have been changed, go ahead and hit the right params button in the bottom left-hand corner. We can now move on to the final section of this video, which is setting up a motor kill switch in both Ardupilot and our transmitter. Navigate to the User Params page in the Config section, and in the drop-down menu for RC7, select Motor Emergency Stop. This will make it so that when channel 7 is activated, all motors will immediately stop spinning. Now we need to set up our transmitter so that one of our switches is assigned to channel 7. For demonstration, I will be using a FlySky i6X. Long press the OK button and then use the up and down buttons to navigate through the menu. Hit the OK button once more when you overfunction setup. Once here, you can use the up and down buttons to scroll through the menus. Scroll down until you reach the aux channels section and then hit OK once more. Here you will see the list of channels that the transmitter supports and which switch they are assigned to. In this section, the OK button is what is used to switch between the different channels, and the up and down buttons change which switch they are assigned to. Now, to set up our kill switch, scroll down until you reach channel 7 and then assign a switch of your choosing. In this case, I use switch A. Once this is done, long press the cancel button to save your settings. You can now test this function by arming your drone without props installed and activating the switch. If all motors immediately stop, then you have correctly set up a motor kill switch. With that, the setup of our S500 build is complete and we are ready for our first flight. Thank you for watching these videos on the S500 with the Matek F405 flight controller. Enjoy!